Hi, welcome to Thermodynamics 5. In this lesson we're going to talk about something completely different, which is just a few cool ideas that also explain how planes fly. Except it doesn't really, but it also sort of does. Right, so what we have here is a diagram of a pipe and the water running through a pipe. These things are called streamlines. And they are a representation of fluid movement that we use in physics. The only thing you really need to know about streamlines is they represent how the fluid is moving at that point. So if a bit of fluid is here, it's moving that way. And the closer they are together, the faster it is moving. So the liquid in the centre of the pipe is moving faster than the liquid on the edges of the pipe. Now there's a simple reason for this. Pause the video to see if you can work it out. The answer is friction. The water on the edges of the pipe is rubbing up against it, and that's slowing down its motion. The water in the middle of the pipe is rubbing up against this slower moving bits of water, but that's less friction than against the edges of the pipe, and thus it'll move faster. So if you do ever get trapped in a massive sewer pipe in some sort of Goonies-esque scenario, do try and get to the edge, the water will be moving slower. Unfortunately, in said Goonies-esque scenario, you're going to have a problem because of something called fluid pressure. Turns out whenever there's a fluid, and by a fluid, remember in physics we mean a gas or a liquid, the faster it is going, the lower the fluid pressure is, and there is a force towards low pressure. So wherever we have low pressure in a pipe or in the air or whatever, there'll always just be a force moving things towards it. You may have been in open water at some point in your life. Maybe you've been in the sea or in a river. And you might have noticed that when there's a current, it tends to pull things into the current. Things get pulled towards it. This is the reason why. Currents are faster moving bits of that liquid. Because they don't have lower pressure, there's then a force towards them. Meaning you actually get sucked into the fast part of the river, or if you're trying to stay clinging to the edge of the pipe, it'll actually suck you into the faster part. Creepy, eh? All of this explains the so-called Bernoulli effect, which is part of, but not also not, the reason that planes work. There's a lot of argument over how to explain how planes work and whether even to teach the Bernoulli effect and so on and so forth. It is real, it doesn't fully explain planes working, but it also explains it enough that it works. And hey, everything's a story, right? So, here is a wing, and what we're doing is we're looking at it side on. So if the plane's flying like this, it's as though you're looking down the wing like that. We cut it in half. And what we're going to do now is we're going to look at what happens to air as it hits the wing. So the air's just going to come in like this, not very interesting, but then some of the air is going to go underneath it like this, and some of it's going to go over the top like this. Now it turns out if the air is pushed over the wing, it's got a further and longer distance to travel, meaning that it'll have to go faster than the air going underneath the wing. So now what we have is fast air going over the top of the wing, slow air going underneath the wing, which means we've got low fluid pressure here, high fluid pressure here, and we know there is a force towards the low pressure, and that gives the wing lift. So just go through that one more time. Air goes fast over the top, slow underneath, lower fluid pressure above, therefore you get pulled up. And this is, at a very basic level, how a wing works. Now, of course, there's a very simple argument against this, which is planes can fly upside down, which rather kills this, and it turns out the real answer is more complicated. But this is still happening, and it is real, and it's a cool thing to know. Great. I'll see you tomorrow.